So, okay, we're talking about inheritance. Okay, so I have given you one example, like how, like in which situation we say that it's inheritance. It's a situation of inheritance. When we have anything, any real world entity or any object we're talking about, if we don't get a concrete information from that, and when we try to say something specific about that, then we deal with two or three different sort of things, two or three different sort of entities. As I have given you example of vehicle. So vehicle, if you say it's a vehicle, it's not concrete, it's an abstract statement. Okay, we're not sure what type of vehicle is it, what are the different properties of that vehicle, what are the different functionality of that vehicle. But when we say it's a car, we are a little more specific. We say that, oh, this is a car, it's a vehicle, but it's a car. And when we say it's a bike, we know, oh, it's a vehicle, but it's a bike. It's more specific when we say it's bike, it's car, that way. So everything that we deal with, everything that we say, if it's a specific object, if it's a specific implementation, then we say that it has inherited some property from its parent, like from its vehicle property. We say that a vehicle can run, a vehicle can go some distance, it can move some distance. A vehicle used to have some wheels, but we don't know how many wheels it is having. So when we say it's vehicle, we'll give the specification of the vehicle that, yeah, it can move up to some x distance, that's fine. A vehicle, it will have some number of wheels, so I don't know how many number of wheels it is having. When I say car, I give the implementation, I tell that specifically this vehicle is having four wheels, this vehicle used to move this at this speed, this vehicle is consuming this much of fuel. So at that point of time, when I talk car, when I talk about uh, bike, I tell that it's having two wheels and a number of like person who can sit on that bike, a number of person who can like accommodate in that car. So these are the proper implementation of the super vehicle. So the vehicle is a super class or a super entity with some limited number of properties, a limited number of functionalities, and a car is the concrete one with all the functionalities or all the implementation of its super. So I'm going to give you the same example over here. So we're going to look at this example in which I'm going to create a class vehicle. Okay, done. So this is a class vehicle, and we know that this vehicle class is going to have some number of wheels, like int number of wheels, and I don't know the value, like the number of wheels, how many wheels it's going to have. Okay, and there are certain properties of the vehicle which are implemented differently. If it's a bike, it's going to be implemented differently. If it's a car, it's going to be implemented differently. So there can be a method which is saying, like the method name is public integer, like number of accommodations, for example, or number of passengers, to be more specific. Okay, so I can say that get number of passengers. So a vehicle, all the vehicles, there used to be passenger, it's not going to be empty. Okay, so they're going to have this functionality. So it's going to return at least one. So there may be certain vehicles in which only one person can go. So the vehicle said, okay, if it's a vehicle, at least one person can go. So that's it, it's done. And when I'm trying to like create the object of this class, I should have a constructor. So the constructor I'm going to create is public and name of the class vehicle, and it's going to take one argument, that's int number of wheels. So it's going to construct itself, so it's going to assign this dot number of wheels equals to number of wheels. Fine. Now basically what is happening, I'm trying to create a new vehicle object, so I'll pass the number of wheels this vehicle is having, that's it, then it's done. Then I'm having a vehicle class or its new object. Fine. Now I'm saying that okay, it's not same always, it used to be different for different types of vehicle. So let's do one thing, let's create a specific or a concrete type of vehicle. So I'm going to tell that I'm going to create a car. So class car is something which is going to have certain properties of its own, right? So it can have get number of passengers, public int get number of passengers, and it's going to return you 4, like 4 people can accommodate in a car or it can be 5 including the driver, that's fine. Or let's do one thing, let's keep it 4 because we're talking about passengers, not the driver. Okay, fine. So now we have the car object. If you create the object of this car and if you ask get me number of passengers, it will tell you 4. But again, this car is a vehicle, so we need to have int number of wheels as well. Okay, and if somebody is creating the car object, so how he'll do, we'll have to create one constructor, public car, then somebody is going to pass the value like how many wheels do you have. But we don't need that because we know the car is having only 4 wheels, so we don't need to pass that value. So we're going to assign the number of wheels equals to 4. So when somebody is creating a car equals to new car, it doesn't, like, he doesn't need to pass the number of wheels, it's automatically assigned 4, so it's a hard coded value, that's it. But if you look at these, we already have a vehicle object, okay, we already have a vehicle class, and the car is somehow similar to that, but we're writing the code again, right? We're writing the code again, we're defining the values once again. What we can do is we can basically extend the behavior of vehicle, and we do it on our own, we do it the way we used to behave. The car can extend vehicle, the behavior, the properties of vehicle, and the car can say, okay, I'm having 4 wheels. The vehicle may be having anything because I'm a car, I'm a vehicle, and I'm having this number of 4 number of wheels. So what I need to do is I don't need to define this value, this thing, or I don't need to define the create a new method, get number of passengers. They are already there. So what I'm going to do is I'm going to basically extend the property. The behavior extends. This keyword basically says you are going to extend the way the superclass behaves. So vehicle is the superclass now. That property, all the properties, all the methods, or the functionality of the vehicle is extended in the car class. Okay, so if you look at vehicle, it's a class and car is a class. So when a class is extending the behavior of another class, it's basically, we call it we basically call it extends. Okay, so we have already defined number of wheels, so we don't need to define it. We already have the wheels over here because we have the car, we have the vehicle, so the wheels is over here. So what we need to do is when we create a car, basically we are creating a vehicle first because it's extending the vehicle. So the vehicle is created first. So how to create an object? We need to call the superclass constructor. We need to call the constructor of vehicle. As vehicle is superclass, we're not going to create new vehicle over here. What we're going to do is we're going to call the super constructor. And if you look at the superclass constructor, basically it is asking for a parameter, number of wheels. So we are going to pass the number of wheels over here. We're going to pass 4. That's it. Now the superclass is constructed. So this vehicle is no more just a vehicle, it's a car vehicle because we have passed number of wheels equals to 4. When we pass super 4, this constructor is called and the number of wheels it becomes 4. That's it. So the vehicle's number of wheels is now 4 and we have created a car, it's having 4 wheels. That's it. Okay, when we talk about get number of passengers, okay, basically what we are doing, we already have this method extended, this method available over here in the car. So we can call car.get number of passengers. If you don't write these, that's fine. If you want to call car.get number of passengers, it's going to work fine. It's not going to give you any issue. But as this car is a vehicle and the car is having this vehicles this method available within its body, we can basically call that. So, but the way it is implemented, it's little different. If we call car.get number of passengers, it's going to return you 1. It may be wrong as per your implementation. So what we want to do is we want to override the way vehicle used to do. We want to change the behavior. We want to change the behavior of this functionality, get number of passengers. So what we want to do is we want to override something that is in the class, in the super class. So vehicle is the super, car is the child, or this is the parent and this is the child. Vehicle is the super and this is the base. So these are the terminologies which we mostly encounter when we talk about inheritance. So if we do one thing, if we in Eclipse, if you right click over here, if you go to source and if you go to override or implement methods, so it looks at the class, base class and the parent class, and it shows you all the methods available in the parent class which can be overridden. So if you click over here, it will tell you that so class this vehicle, you can see this arrow, so it's basically the super class, and there is one method get number of passengers. We want to override that. Select the method to override or implement. So we select it to override, and if we click on OK, it's going to be overridden. So now it's giving us the it's giving us a way to basically override the way vehicle basically works. A vehicle get number of passenger works. Now we are going to tell, no, it's not just a vehicles get number of passenger, it's the cars get number of passenger. By default, it's calling the super classes get number of passengers. So when we call this method of car dot get number of passengers, it's indirectly calling superclass, that is vehicles get number of passengers. So if you control and click on it, it will take you to vehicles get number of passengers. So it's returning 1. No, I don't want 1. I don't want to return 1. I want to return 4. So if somebody is creating the object of this car, it's always going to return you 4 if somebody is calling get number of passengers, because we created a car, not just a vehicle, because we have overridden the property of get number of passengers. So this is what happens when we talk about inheritance. We have certain number of functionalities in the parent class, this vehicle, and we override that in the child class over here. And when somebody calls this method, we will return that object's method or that object's property, that object's behavior. So now we have a vehicle superclass, we have a car child class. So what I'm going to do is I'm going to basically create a vehicle now. So to do anything in Java, if you want to execute, you start with main method. We first create an object of this main method of this example. We create a main method in this example class. So I'm going to create it's showing error, save it. Okay, that's done. So I'm going to create a car equals to new car. This is how basically we create the object. This is the constructor that we have called, and we have not passed any parameter. So now what I'm going to do is I'm going to call car.get number of passengers. So if I want to sys out that value, it is going to give me the result. So let's run this method, run, and it's giving me 4. So basically car.get number of passenger is called, so it is returning me 4. Okay, anyways, we have not yet seen how this inheritance has occurred. Let's do one thing. Let's create a new vehicle. Vehicle equals to new vehicle. That's fine, but the constructor is expecting us to give the number of wheels of that vehicle. I can give 3, it can be an auto. Fine, I can give 1. I don't know if any vehicle exists with 1 wheel. So let's give it some value, meaningful value. 4 we have already taken with car, and we have the car implementation, so we're not taking 4. We have not yet discussed about auto. We don't have any implementation of auto rickshaw, so let's give 3. We're thinking that we're creating an auto rickshaw, But we have created this vehicle object. So what I'm going to do now is I'm going to sys out number of wheels of my auto rickshaw object. It's going to print the value of vehicle dot get number of wheels. Seems okay. So let's run this and let's look at the output. Okay, okay, it has, okay, I have sorry, I have called number of passengers, GER. So I'm calling number of passengers of my auto rickshaw object, and if I run it, it's going to tell me the number of passengers in auto rickshaw is 1. But here is the problem. We have tried to create an auto rickshaw, but it's giving me the some value which I'm not aware of. It's giving me some value of its super, like of its own, which is already created, and I don't have any flexibility, I don't have any option to specify the number of passengers that can be accommodated in the auto rickshaw. So what I'm going to do is I'm going to create, because this is a vehicle, this is not a complete object. I have like created, I have told the vehicle object to have 3 wheels. Okay, it's having 3 wheels, but when I want to like tell, okay, I want to have only 3 passengers in my auto rickshaw, not more than that, I'm not able to do that. So how to do that? So I already have a car object. Similarly, I'll create a new object, a new extension of vehicle. Over here I can have one more extension, and I'm going to call it class auto rickshaw. Rickshaw, auto rickshaw extends vehicle. Done. Now auto rickshaw object, okay, we have created. It's throwing some error. It says that if you want to create this auto rickshaw object, classes object, as it is extending the vehicle, you need to tell how this vehicle object to be created first. So we're going to have a constructor for auto rickshaw. This is the default constructor, and within that constructor I am going to call the super, and I'm going to pass 3. So basically it's passing the number of wheels it can have in the super. So if you go to super, it's saying number of wheels and you are assigning 3. That's fine. Now we have created that. Now I want to extend the behavior of how many number of passengers I can accommodate. So I'll write override, this is the annotation, and I'm going to write the method public int get number of control space. Okay, it's not giving, get number of passengers. Fine. Now it's going to return the number of passengers as 3. Now the auto rickshaw object is created. So when I call vehicle, new vehicle, I don't need to create new vehicle again. I'm going to create an auto rickshaw object. Okay, let's comment this out. We'll come to that. Auto rickshaw, like rick equals to new auto rickshaw. And when I'm creating this object, it's indirectly creating the vehicle object. If you go to this constructor, it's creating the super constructor, calling the super constructor as passing 3. So the number of wheels has become 3 now. And I'm calling the get number of passengers now. Let's see what it is giving me. So basically I'm calling rick dot get number of passengers. That's fine. So it's okay. Now let's run this code. Okay, it's no more going to give us 4 or 1. It's going to give us number of passengers as 3. Fine. Now there is one property, as I said you, this car, this auto rickshaw, they are all vehicles. So a vehicle can be a car, a vehicle can be an auto rickshaw, but we are not sure about that. That means a vehicle is the parent and it can accommodate a car, it can accommodate a rickshaw. If you talk about a vehicle, it can be a car, it can be a rickshaw or anything. So as the parent is something, it has the capability to be a child. This property of Java we call as polymorphism. So in Java there are a lot of in OOPS there are a lot of concepts of OOPS. There are a lot of like building blocks of OOPS we say. So this is one of them. So when we talk about the parent, it can accommodate any of its child, any of its children. So if we say I'm talking about a vehicle, so you can create a vehicle reference, okay, but it's not mandatory to have the object of its own. It can have one of its child objects. Copy and let's pass it over here. See, I'm creating a vehicle, but I'm passing the value. I'm creating the object over here. I'm creating the object of his child, and I'm assigning the reference to a parent. So I can do one thing now. This vehicle is basically a rickshaw, so I'm just naming it as Rick. Okay, so I'm telling that vehicle Rick equal to new auto rickshaw. So this vehicle can accommodate a rickshaw, or this vehicle can also accommodate a car. If I want to do it this way, I can comment this out and I can make it car equal to new car. So this car object that is created, it's basically inheriting the property of vehicle, and it's allowing the vehicle to basically hold the object, to basically point to the object that is created by car. It's pointing, the vehicle reference is pointing the object that is created by rickshaw, because these are the child objects. This behavior of Java is called polymorphism. A single polymorphism basically means poly means many, morphism means morphs or forms. A single reference can act as different forms, can have different forms at runtime. So a car, like a vehicle, can have can be a car or it can be a rickshaw. So let's do one thing. Let's make it vehicle. Okay, now we have a vehicle. At this point of time, this vehicle is a car. Later on, what I did is I'm basically assigning this vehicle with a rickshaw. See, this line, the vehicle is a car, and this point of line, the vehicle is a rickshaw, and they are working fine. I need to have the reference over here. So I'm not sure about the object that is present, but I'm calling some of the reference, some of the methods, some of the properties of the parent class, and they are somehow like implemented by the child. I don't know the implementation. I'm just talking about the parent. I'm talking about the parent, the vehicle dot get number of passengers, but it will give me the passenger within the rickshaw. So let's save the code and let's run this and let's look at the behavior. See, I'm calling the vehicle dot get number of passengers. So let's run it. Okay, if it's a it's a car, the get number of passengers is 4. And if it's the rickshaw object over here and get number of passengers, it is saying it's 3. See, the same vehicle of reference, it has acted differently. The same method is called over here, the same method is called, but the object it has accommodated, they are different. So at runtime, it specifies which object, which method of which object it needs to call. So this is the behavior of what we call it polymorphism.